Now we have special angles. So let's grab a pen and we draw a triangle, one triangle. There we go. Second triangle. And the one triangle is of 45 degrees. The other one is one angle is 30 degrees and the other one is 60 degrees. Third angle is 90 degrees. And we draw a small circle. This is just a rough sketch, so just to explain to you, right, what's happening. This point is your minus 1 is to 0. This point is your 0 to 1. This is R1 to 0 or your 360 degrees will be here and the point will be 1, 0, and this will be 0, negative 1. So these are the points on the Cartesian plane. So please remember the mnemonic. SOHCAHTOA. We know that we are working with the angle 45 degrees. So sin equals sin angle is 45 degrees, right? So we are going to say that, okay, we know that trig ratio sin is equals to opposite over your hypotenuse. So looking at the 45 degrees triangle, we will say the opposite side is 1 and the root 2. Now, if I give you cos 45 degrees, adjacent over hypotenuse, this will be 1 over root 2. And then tan 45 will be your 1 over 1. Now again, we move on to the different triangles. So sin 60. Sin 60, we say that sin ratio is opposite over hypotenuse. Again, we will say that this is root 3 over 2. Why? Because if you're looking at the triangle from this side, if you're standing here, from this side, the opposite side is the The side of the triangle opposite to this angle, which is our reference point, or the angle we are looking at, is the opposite side. That's why we say for the sine 60 degrees, root 3 will be the opposite side, and the value of your hypotenuse side is not root, just the two. Hypotenuse is the longest side of the triangle. So this is the ratio. Now we have tan 30 degrees, that will be 1 over root 3, and then we have cos 90 degrees, which is equal to 0, and we have sine 270 degrees, which is equal to -1. Your tan 360 degrees is equal to 0. Now, this is other special angle. So, in the exam, they can ask you to simplify the special angles without using the calculator. So, as long as you're not giving me answers in the decimal form, your calculator can do this for you. So, please grab your calculator, type sine 45 degrees, and see what your answer comes in. Your sine 45 degree is equal to, it will give you the same values. Now we move on to the next part. Now we are going to look at the actual exam questions. Now let's start from this side. We say simplify without using your calculator. The question for you here is sine 80 degrees times cos 120 degrees will give you cos -10 and your sine 150. Just a quick question before we move on. Did Mr. Hugo start Euclidean geometry with you?
Can you please repeat, ma'am?
Sorry?
Can you please repeat?
Okay. I'm saying, did Mr. Hugo start Euclidean geometry with you? Did he start teaching you that?
Ma'am, I can't hear you. What geometry?
I'm going to use the chat box. Did you do this section with you? Check your chat box. I've written the name of the section. Okay. Okay, no problem. Okay, so we have simplify without using your calculator. Sin 80 times cos 120 degrees over cos minus 10 and sine sin 150 degrees. Now sin 80 is fine, right? We can write this as it is. Now we have to use cos 120 degrees. This is the problem. We are going to use the reduction formula. Now, to use the reduction formula, we are going to say cos 120 degrees. We are going to say that cos 180 minus 60 degrees, which will give us 120 degrees. So 180 minus 60 is equal to 120. So this can be reduced to cos 180 minus 60 degrees. Now coming to the cos negative 10. Cos negative 10 mean that again, cos negative 10 mean negative angle we measure um, uh, from x-axis in the clockwise direction. The quadrant 4, negative 10 will come in quadrant 4, and this will become your positive cos 10 because quadrant 4 is the cos quadrant. Therefore, the angle and the cos value will become positive. Now, we are going to again face one more problem, that is sine 150 degrees. Again, use your reduction formulas here. Okay, so now we have this, right? We have reduced this formula and we got this. Now sin 80 and cos 10, they can cancel out. Why they can cancel out? Because they are the co-functions of each other. Remember we did the co-functions here. This sin 10 and so this part here is your co-functions. Now sin 80 degrees and cos 10 cancel each other out, and now now cos 180 degrees minus 60 will become negative cos 60, because 180 minus theta, 180 minus theta is in the quadrant where cos is negative. So the cos will become negative, and we have negative cos 60 degree. And then sine 180 minus theta is, so now sine 180 minus 30 will become the plus sine 30. Why? Because this is the sine quadrant. Now, cos 60 and sine 30 is our special angles. So, by using your calculator, you can say minus half over the half and half will cancel out, and the answer will be minus 1. So as long as you are, you can use, if you forget your negative angles, right, you can use calculator to remember what is the value of cos 60, what is the value of sine 30. But please don't ever write trig ratios, any type of trig ratios in decimal form. Always use fractions, and then they won't know that you are using calculator, even if you forget, right? This is you can say just a hack to get everything sorted if for some reason you get confused or you tend to forget things, right? So this minus cos 60 will become your negative half. Sine 30 will also become your half, and then this will cancel out, and this will give you minus 1. Now let's do the sum, the question where you have to prove an identity. Okay, now
Ma'am, I can't see by the
now
two by the two cos square x. I can't see that part.
okay. Okay, let me just write it again. This is cos x plus 1. Now at the bottom, okay. Now we have a question which says proof cos x s cos 2 cos squared x plus 2 cos x will give you plus 2 cos x plus 1 over 1 minus cos squared x is equal to 1 plus cos x over 1 minus cos x. Now the question says proof. Proof mean we are dividing this question into two parts. There is a left hand side and there is a right hand side. So this is your left hand side and this is your right hand side. In order to prove identities, we must be able to go and spot algebra in these type of questions. For example, if you look at cos squared x plus 2 cos x plus a, in algebra we can say that this is a squared plus 2a plus 1. Correct? Now we can simplify this or factorize it by saying a plus 1 and a plus 1 will give you a squared plus 2a plus 1. Now, we are using left hand side to prove that this side is equal to the right hand side. So, we are using this side. Now, in the next step, we can say that, okay, we spotted the algebra because of this 2 and then this 2 here. We can say that the cos squared x plus 2 cos x plus 1 is same as cos x plus 1 and cos x plus 1. So this was the numerator. Now look at the denominator. 1 minus cos squared x. Now in algebra, we say 1 minus a squared. And this is the difference of 2 squared. So we say 1 minus a and 1 plus a. Now, this will become 1 minus cos x, 1 plus cos x. Now, look at this carefully again. We can cancel out cos x plus 1 or 1 plus cos x. And then we are left with cos x plus 1 over 1 minus cos x. Now look at the right hand side, this side. So it is 1 plus cos x, 1 minus cos x. Since then we proved the identity that left hand side is equal to right hand side. Or what we can do, just to avoid confusion, we can rewrite this by saying 1 plus cos x over 1 minus cos x, and hence we can say it is proved that left hand side is equal to your right hand side. Any questions?
No.
Okay. Have you written this down? Can I erase this part? Um, uh, can I erase this part? Wamin,
Ma'am,
are
can
you
you
there?
repeat?
Okay, I'm saying, did you write this part here?
Yes, I
When I was
did.
explaining the algebra, so I can erase this, right? We don't need this
Yes.
anymore. We are going to look at the compound angle for cos A minus B. Now, let's just divide this part in the like this. Okay, now we have compound angles for cos A minus B. We say for the compound's angle, um, they are called your compound angle. And we can use the formula cos alpha minus your beta, and that is equal to your cos alpha cos beta plus your sine alpha and your sine beta. Okay, so this is the formula or how we can define the compound angle. So when we have this cos alpha and minus beta, cos beta, we can expand this by saying cos alpha sine beta or cos beta sine beta, or you can say cos alpha cos beta and sine alpha sine beta. So there is these two alphas here and there is these two betas here. And if with the cos angle, we have a negative sign in the brackets. Then to expand, we will write the positive sign. So now we are going to look at each example, and using the compound angle formula, we are going to expand the example. So let's look at the question. Did you manage to finish your assignment?
No, ma'am.
You're still struggling with the assignment. What's happening there?
No, ma'am. The only part that I was struggling was the trigonometry, but since you've explained it, so I'm like completed. Hello.
Okay, and when are you going to submit it?
I'll submit it, ma'am, because tomorrow I'm writing business, so I'll be busy with my business. But then I'll submit it on Monday.
No problem.
Okay.
Okay. Okay. Because please try and submit it before the due date. So if you have like a lot of mistakes and I see that there's a problem with the assignment, then I can give you a quick review and then you can rectify your mistakes before giving me the final copy of your assignment. Okay, this will make your life easy too. Okay, for example, if I give you cos x minus y, we are going to write the pattern first, right? So notice this pattern: cos, sin, sin. We have this question now: cos x and cos y. So we are going to write the pattern. So we are going to say cos, cos, and sin, sin. Now the angles here are your x and y. So we say x, y, x, y. And then we are going to look at the a sign which says that if it is negative in the brackets, then there will be a positive sign. So we see that there is a negative sign in the bracket, we are going to add the positive sign. So this is your expanded form of cos x minus y. Now let's look at another question, which is your question number 2. Cos a minus 60 degrees. Now again, we are going to write the pattern: cos, cos, sin, sin. We have alpha, A and 60. Now we are going to write the angles. We're going to say A, 60, A, 60 degrees. And then look at the sign in the brackets, it is negative. So we are going to add the positive sign. Yes, try this for me, Awami. Try and Give me the expanded form of this compound angle using the compound angle formula. Yes, please try this for me. Either write the answer in the chat box or you can unmute and answer me using the microphone. What will be the expanded form for the question number 3? Okay, no problem. Okay, let me explain to you again, right? So we have first, when we are looking at compound angle, right? Cos alpha minus beta. This is always given in the formula sheet which comes with the exam paper. Sometimes they give you the second part, sometimes they don't. And so cos alpha, cos beta plus sin alpha, sin beta. So this is the pattern we are going to use to expand this compound angle. For example, alpha can be anything. It can be A, 3x, B, C, D, 40, anything. Beta can also be anything. Y, 60, 40, X, 1, 2, 3, anything it can be, right? But the pattern is to notice here that we have two cos, we have two sin, right? This alpha, there is this alpha 1, there is this alpha 2, there is beta, this beta 1 with cos, and there is 1 beta with sin. And then negative angle here, negative formula is changing into the positive formula. So we say that cos alpha minus beta, oops, right? We have two cos and we have two sin. Now we have this alpha. This alpha will go here and with sin. One alpha will go with sin. Then we have this beta here. This beta will come with this cos and this beta will come with this sin, right? And then we are going to look at the sign in between. This sign is negative. So this will become here positive. Understand so far? Now, we have this which is similar to alpha minus beta, cos alpha minus beta, cos 3x minus 45. Again, we are saying that when we expand, there is a pattern. We are going to write cos, cos, sin, sin. Cos, cos, sin, sin. So one angle alpha, in this case alpha is 3x, will go with cos and then another sin. And then another angle beta will go with another cos and the sin. So let's divide. So this 3x is coming here, 3x, sin 3x, and this 45 degrees is cos 45, sin 45, right? And then we say minus, minus will change into the positive sign. Question number 4. Cos A minus B. Yes, now try and expand it for me. Yes, Ovami, give it a try. Cos A minus B, give me the expanded form. Yes, little bit focus. Cos, sin, then we look at angle A. We divide, we give 1A or 1 alpha to cos, 1 alpha to sin. Then we have beta, we give 1 beta to cos, we give 1 beta to sin. Then we look at the negative or positive sign in the bracket and we change it to the opposite. If there is negative sign in the bracket, we say positive. If there is positive sign in the bracket, we say negative. So this is how you will expand the compound angles. So cos alpha minus beta. First step is to write cos sin sin. Can you do that for me? Write cos sin sin. Yes, are you with me? Yes, Ovami, I'm waiting for you. We can't move forward if you don't understand this step.